two charged particles placed at a separation of 20 centimeters exert 20 Newton of Coulomb force on each other. What will be the force if the separation is increased to 25 centimeters? So Coulomb's force is given by F equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. So here F1 is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by 0.2 square equal to 20 Newton. F2, which is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by 0.254 square is to be found. So from here, we can get the value of Q1 Q2 divided by 4 pi epsilon naught. So this will be equal to 20 times 0.04. This value we can place here. So F2 equal to 20 times 0.04 divided by 0.254 square. This will become 20 into 0.04 divided by 625 into 10 to the power minus 4. So if we simplify, this will become 12.8 Newton, which can be written as 13 Newton. Question next. The force with which the Earth attracts an object is called the weight of the object. Calculate the weight of the moon from the following data. The universal constant of gravitation is 6.67 into 10 power minus 11 Newton meter squared per kg square. Mass of moon is 7.36 into 10 power 22 kg and mass of Earth is 6 into 10 power 24 kg. Take the radius or distance between Earth and the moon as 3.8 into 10 power 5 kilometer. Now, force will be the weight. So force is given by Newton's law of gravitation, G equal to M1, M2 divided by separation square. So F equal to G 6.67 into 10 to the power minus 11 into mass 7.36 into 10 power 22 into 6 into 10 to the power 24 divided by separation square 3.8 into 10 to the power, this is 5. So we can write it 8 because this is in kilometer. We have to write it in meter square. So this will become 6.67 into 6 into 7.36 divided by 3.8 into 3.8 into 10 to the power minus 11 plus 24 plus 22 minus 1600. So this will become 20.4 into 10 to the power 19 or 2.04 into 10 to the power 20 Newton. Question number 10. Find the ratio of magnitude of electrostatic force and a gravitational force acting between two protons. So Fe upon Fg is to be found. Fe will be, since electrostatic force is given by 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. So here value of 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. And this is protons. So protonic charge 1.6 into 10 power minus 19 whole square divided by r square, and F gravitation 6.67 into 10 power minus 11 into mass of proton 1.67 into 10 power minus 27 whole square divided by r square. Here we have to get the ratio of the two. So numerator 9 into 10 to the power 9 into 1.6 into 1.6 into 10 to the power minus 38 divided by 6.67 into 10 to the power minus 11 into 1.67 into 1.67 into 10 to the power minus 54. So 9 into 1.6 into 1.6 divided by 6.67 into 1.67 into 1.67 into 10 to the power. From here, it will be 9 minus 38. From here, this will be 11 plus 54. So we can simplify it. So it will be equal to 1.24 into 10 to the power 36. Question number 11. The average separation between the proton and the electron in a hydrogen atom is in ground state is 5.3 into 10 power minus 11 meter. Calculate the Coulomb force between them and this separation. So here there is proton, here there is electron, proton, electron. Force will be equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. So that will be equal to 9 into 10 to the power 9 into charge 1.6 into 10 power minus 19 whole square, because charge on proton, charge on neutron in magnitude, sorry, charge on proton and charge on electron in magnitude are same, divided by separation is given as 5.3 into 10 to the power minus 11 whole square. So this can be simplified. 9 into 1.6 into 1.6 divided by 5.3 into 5.3 into 10 to the power minus 38 plus 22. So this will come out to be 8.2 into 10 to the power minus 8 neutron. So this is answer to first part. Now, when the atom goes into its first excited state, the average separation between the proton and the electron increases to 4 times its value in the ground state. What is Coulomb force? Now, in B part, this separation becomes 4 times. So F equal to rest value will remain same in power 9, 1.6 into 10 power minus 19 whole square. Here 4 times this value. So 4 square is 16. So we write 16 separately, and the rest thing 5.3 into 10 to the power minus 11 whole square. So whatever value we have got, that will get divided by 16. 8.2 into 10 to the power minus 8 divided by 16. So this will become 5.1 into 10 to the power minus 9 Newton. Question number 12. The geostationary orbit of the Earth is at a distance of about 36,000 kilometers from surface of Earth. Find the weight of 120 kg equipment placed in geostationary satellite. The radius of Earth is 6400 kilometers. The center of Earth, this is radius of Earth, and satellite is here. This height is 36,000 kilometers, and this is 6400 kilometers. So the center, this is point of satellite. So distance will be taken as SC, that is 36,000 plus 6400. So say R equal to 36,000 plus 6400, which is equal to 42,400 into 10 to the power 3 meter. Now, we have to find out the force. Force is G m1 m2 divided by R square, 6.67 into 10 to the power minus 11 into mass. Mass of Earth is 6 into 10 power 24 kg, and mass of satellite here, not satellite, but that of equipment is given as 120 kg divided by separation square 42400 into 10 to the power 3 whole square. Now we simplify it, 6.67 into 120 into 6 into 10 to the power, from here it will be 13 minus 11 plus 24, and from here we can take two zeros, this 20 and 3, 10 power 5 and whole square 10 power 10. So here we can write it as 10 power minus 10, and then divided by 4 to 4 into 4 to 4. Now we simplify. So this will become 0.0267 into 10 to the power 3, which will be equal to, we shift the decimal to 3 places forward. So this will become 26.7 Newton, and that is our answer. Thank you for watching.